Welcome to EDU World Space.
So we have a rocket ship orbiting Mars. So Mars is the red planet here. So this rocket ship is orbiting Mars and it's 2,000 kilometers away from the surface. It really wants to be 4,000 kilometers away from the surface. So we want to know how much work it's going to take to get from 2,000 kilometers to 4,000 kilometers. So for the sake of argument, we have R1. Our R1 is a measurement of 2,000 kilometers distance, which if we were to say 1 kilometer, it's going to be 1,000 meters, right? I'm going to knock that out. We're actually going to get 2 million meters. Now for our R2, that's going to be 4,000 kilometers. Going to do the same conversion. You're going to get 4 million meters. Okay. So let me quickly, 4 million meters. So once again, we're orbiting around Mars, so that's good to know. So the mass of Mars is going to be 6.42 times 10 to the 23rd kilograms. Okay. And other relevant information, we know we're going to end up needing our gravitational constant. That's kind of been a running theme in this chapter. So that's going to be 6.67 times 10 to the 11th. And that's going to be in newtons per meter squared, kilograms squared. So this is all kind of the information that we really need. Now, when we talk about how to figure out how much work it takes for us to get from R1 to R2, right? It's really a change in gravitational potential energy. So work is this change in gravitational potential energy. And we were given an equation for this. So the equation for gravitational potential energy, once again, kind of derived from Newton's law of gravitation, is going to be negative g, our gravitational constant, times the mass of the planet. So here we're the mass of Mars. And it's also going to be multiplied with the mass of your object. So in this case, it's our rocket, right? That's going to be over the distance that it's at. So we have two distances, so we're going to have to do this twice. So negative delta U is going to be equal to negative G times Mars mass times the rocket's mass over R2. Because remember, our delta is going to be the second minus the first, right? Super important to remember. And we're going to subtract that once again, negative G times mass of Mars times mass of the rocket over R1. Now, just a heads up, something to notice is that both of our numerators are the same, right? So we can factor that out. So what we're really going to get is a negative delta U equal to negative G times the mass of Mars times the mass of our rocket. And we're going to multiply that with 1 over R2 minus 1 over R1. Now we got a little bit lucky here because when we write this out, we're actually going to end up having negative delta U equal to negative 6.67 times 10 to the 11th times 6.42 times 10 to the 23rd times 5,000. And it's going to be 1 over 4 million, right? 4 million, goodness me, minus 1 over 2 million. 3, 4, 5, 6 zeros. Cool. So this all kind of pans out, especially this stuff in the brackets, right? This stuff in the brackets right here, that's really just 1 over 2 million. Awesome. So if we were to work this out, so let's go ahead and bring it up here. So if we were to work this math out, our negative delta U is going to equal negative 2.14 times 10 to the 17th. And we're going to multiply that together, right, with our, oh, this is not 1 over 2 million. This is going to be 1 over 4 million. So I'm going to go ahead and correct myself real quick. So it's going to be 1 over 4 million, right? And it's not just going to be, yes, it's going to be 1 over 4 million. So this is going to end up being 1 over, yes, 1 over 4 million, 1 over 2 million, 2 over, yes. So this is going to be 1 over 4 million. Good. Sometimes we all need to double check our math. All right, 1 over 4 million. When we do this out, negative delta U, once again, is going to be equal to the work being done, is going to end up being negative 5.35 times 10 to the 10th. So once again, negative here, which means our work being done has to be positive. So our work is positive 5.35 times 10 to the 10th. This is going to be in joules. And if you need to kind of convince yourself of that, we have newtons per meter squared, kilograms squared. This is going to be multiplied by a kilogram and a kilogram, right? And that's going to be multiplied by meters. Specifically, 1 over a meter, right? So we're going to have boop, meter, cross those out. We're going to cancel out these kilograms. This is kilogram squared, so that's going to cancel out. So we have newtons per meter, which is a joule. So our units check out. Therefore, we get our answer.